So in this particular average speed problem, we're given two different airplanes traveling away from each other, moving in an opposite direction at two different rates. So in the diagram here, you have airplane 1 moving to the left, and you have airplane 2 moving to the right. So if you want, take a second, pause the problem, and read the prompt. Okay, let's go and get started. It says the first plane is moving at a rate of 25 kilometers per hour slower than the second airplane. So visually, the airplane on the left here is flying slower than the airplane on the right by a difference of 25 kilometers per hour. And it says in 2 hours, the airplanes are 140 kilometers apart, and find the rate of each of the plane. So common sense tells us that in 2 hours, both of these airplanes will cover different distances because they are not moving at the same speed. Okay, so D1 and D2 will not be the same. So let's go ahead and attack this problem. So I would highly encourage you to set up some sort of chart just to keep your information organized. So here I have plane 1 in green, plane 2 in red, just based on the diagram there. And then I would normally start off with the average speed function, which is equal to distance over time. So I did that on the left and on the right. So this one is a little tricky because you have to know what term is the same and what term is not. So in this case, we don't know what the average speed for the first plane is. So I would just say, just leave it alone and carry it down. We know that D1 and D2 are different because they're flying for the same amount of time, but the rates are different, so therefore the distances covered must be different. The one thing we do know is that the time is the same because it says in 2 hours the planes are 140 kilometers apart. So that is one thing they do have the same. Okay, so keep that as we proceed throughout the whole entire solution here. All right, so let's go ahead and find key important information. This is crucial to solving this problem. It says that the plane on the left side, which is denoted plane 1, is traveling at a rate of 25 kilometers per hour slower. So that's really important. So I'm going to try to use that as we trickle our work down. Okay. So that piece of information leads me to the second line here in my work for airplane 1. The speed of airplane 1 is 25 kilometers per hour slower than the second plane. So I can substitute S1 for S2 minus 25. Okay, S2 in this case being the faster airplane, and if you subtract 25 kilometers per hour as stated in the problem, that'll give you the speed of S1. So this is a really crucial step. So if you need to pause the video and understand the substitution there. Okay, and then D1 is unknown because I don't know how far the left plane has flown for, but what I do know is that the time that it's in the air that's being assessed here is 2 hours because it states so in the problem. So the denominator is just 2 because it's given to us. Okay, and we can do the same on the right hand side. I don't know what the average speed is for the second airplane, so I just went ahead and call it S2, and then D2 is also unknown, so I went ahead and just carry that down. T2, I replaced it with 2 because it's 2 hours of motion. All right, so from here it looks a little messy because we have a few things that are unknown. We have an S2 that's unknown, we have a D1 that's unknown, we have an S2 on this side that's unknown, and we have a D2 that's unknown. So if you really look at it, there are 3 unknown variables and we only have 2 functions to kind of play with. So we have to do a little bit of thinking here. Okay. So in order to solve this particular problem, the other key information that you should know is that the 430 kilometers given in the statement is composed of the distance traveled by both airplanes. So while one is moving left, the other one's moving right. If you add up those two distances, you get 430 kilometers because it said so. So that would suggest that you need to solve for D1 on the left side. To solve for D1 on the left side and multiply both sides by 2. So that's where my work looks like. 2 outside the parentheses here. I don't know what S2, I'll leave that alone, and then minus 25 because again, airplane 1 is moving at a rate of 25 kilometers per hour slower. And then on the right side, I will go ahead and solve for D2 simply by multiplying both sides by 2. So it'll give us 2S2. And then just to remind you, this step is crucial, and this is usually where kids struggle, that you don't know to solve for D1 and D2. But it has to make sense, okay? from the given statement, it says that the two planes are moving apart. So therefore, I know that if I solve for D1 and I solve for D2, if I add those two distances up, it'll give me 140. And so this is kind of the key to unlocking this problem. So therefore, with that, I can set up my next statement. D1 plus D2 must equal to 430 kilometers. And then I know what D1 is from the previous work on the left side of the table. I know that D1 is simply 2 parentheses S2 minus 25, so I can substitute that in. And then I also know that D2 in the red on the right side is simply 2S2. So I can make these substitutions here. So instead of having two unknown, which is D1 and D2, I can go ahead and substitute D1 and D2 for something else that I do know. So if you see the substitution here, the only thing left that's unknown in the statement is S2. So really what you're doing is you're eliminating unknown variables one by one. Okay. So let's go ahead and knock this out. So since we only have S2 as our unknown, let's go ahead and crank out the algebra and solve for S2. Alright, so let's distribute the 2 to S2 and also distribute the 2 to the negative 25. So if we do that, you get this third line here, 2S2 minus 50 plus 2S2, which is equal to 430. So here we have 2S2, we also have a 2S2, so combine like terms, so that will give us 4S2. I went ahead and moved this negative 50 to the right side with the 430, and that changes to a plus sign. So we have 4S2, which is equal to 480. Therefore, to solve for S2, we simply divide both sides by 4, and S2 comes out to be 120 kilometers per hour. But the question is asking us to find the rate of each of the plane. So we already found the faster plane, in this case S2 moving to the right at 120 kilometers per hour. And to find the rate of the plane going to the left, which is S1, it's super easy. We already know from the start of the problem that S1 is simply the speed of the second minus 25 because it's moving at a rate of 25 kilometers per hour slower. So therefore, we can just simply use that statement. In my work here, we can say S1 is S2, which is the faster plane, subtract 25, and when you subtract, you're getting a lower value, which is a slower speed for S1 moving to the left. And we just solve for S2, so we can just substitute S2 for 120, therefore 120 minus 25 yields 95 kilometers per hour. Okay, so that's how you do these types of problems. You just have to find these little keys to unlocking these types of problems. All right, I hope that helps.